Today we're going to finish up our chapter on scale factors and similarity in terms of new material. We're going to cover section 4.4, which is on similar polygons. So the really nice thing about similar polygons is if you were okay with similar triangles and you feel like you understood that concept from section 4.3, it's basically the exact same idea, but now we're going to look at shapes that could be other than triangles, so other than having three sides. By definition, polygon, it's going to be a two-dimensional closed figure, and it's made up of three or more line segments. So you have a couple of pictures in front of you. So some simple ones, if you have three sides, the polygon, special name's a triangle. If you have four sides, the generic special name, it's called a quadrilateral. Quad meaning four. As you guys continue on into your high school math course, you will spend a lot of time looking at quadrilaterals and talking about the different types and special names that you have tied to those shapes. If you have five sides, that has a special name, it's called a pentagon. And then if you had six sides, it's called a hexagon. And there's tons of other sides, so you could have 7 sides, 8 sides, 9 sides. You could also have like a 100-sided polygon, but we'll kind of stick with the basics. So we're going to look at similar polygons. Same idea as similar triangles. They have to have the same shape but different size. So again, my example was if I took this picture, this PQRS shape, if I were to zoom it in, make it bigger, zoom out, make it smaller, it's still the same shape, just a different size, right? One is bigger, one is smaller. They have to have equal corresponding angles, and they have proportional corresponding sides. So if we look at our example here, I have this shape, so I'm going to call it WXYZ, and then I have PQRS. So from the diagram, the way that it's labeled, it is saying that angle W, which is denoted with this one little tick mark, again, it's kind of bent, it is equal to angle P. So I notice that those match. So those two angles are corresponding. Then I'll notice, I'll just go in a clockwise direction. It doesn't matter. You can actually go counterclockwise as well. So if I look at angle X, I notice there's 1, 2, 3, 4 little tick marks. Well, I notice that that matches up to angle Q, which also has 4. So I would say those two angles are equal. Keep going around. Angle Y has 1, 2, 3 tick marks, and that matches up with angle R. So I would say angle Y and angle R are equal. And then last one, angle Z, which is denoted with 2 tick marks, is matching up to angle S. Okay, so the picture is showing us that those do have corresponding angles. We don't have the measurements, and that's okay, but I know whatever the measurements are. For example, angle X would have to match angle Q, and angle R would have to match angle Y. Next, we're going to show that they have corresponding sides that would be proportional. So I've cleaned up my highlighter. I understand not really fair if you have already marked up your page. So maybe just do like squiggle lines or some sort of identification. So what it tells me here that WX, okay, is corresponding to PQ. So side WX and PQ are considered corresponding proportional sides. So that would be representing the 12 and the 8. We'll keep going around. Well, the side XY is proportional to the side QR. So XY, which is 18, is proportional to QR, which is 12. And then side YZ, we would say is proportional to side RS. So YZ, which is 15, is going to be proportional to RS, which is 10. And then the final one, side ZW, is proportional to side SP. So ZW is the 9, and it's proportional to SP, which is 6. If we can say that the corresponding angles are equal and the corresponding sides are proportional, then we're allowed to say that the polygons are considered similar. So you'll notice below it says we can say WXYZ is similar to PQRS. Now, something that I think I didn't mention in the similar triangles video is there is a reason why they are labeled this way. Okay, so the order of the letters actually is important because what it tells you is that W is going to be connected to P. So remember up here we said that angle W and angle P are the same. Okay, so the way this is written, then that means that the W has to match the P. Angle X will match the Q, so we said that up here. Angle Y will match R, so we said that there. And then angle Z is going to match angle S. Okay, so if you're ever not given the angles, the way that the question's worded, that's implying that this angle measurement will match this one, this angle measurement will match that one, etc. All right, let's look at our first example. So similar to similar triangles, we are going to look at how to identify whether or not it is a similar polygon now. So this time if I look, there's 1, 2, 3, 4 sides. These would be considered quadrilaterals because of the 4 sides. So the question says, determine if WXYZ is similar to PQRS. Okay, so reminder, if I want to prove that, I have to figure out are the corresponding angles equal and are the corresponding sides proportional. Well, the good news is it's the exact same examples above, so we already know that, right? We went through and we denoted that angle W matched angle P, angle X matched angle Q, etc. So we're going to focus on checking if their sides are proportional. Okay, so I'm going to look at, and you'll notice I've labeled them already. So I'm going to set up big on top, small on the bottom. Only reason I do that is the big shape is first, small is second. Okay, and then I'm going to be comparing, so side length WX, above we said it is corresponding to side length PQ. We'll fill in the numbers after. Then we'll look at side length XY, which is corresponding to side length QR. Then we'll compare that, side length YZ, corresponding to side length RS. And finally, side length ZW, corresponding to side length SR. So if you want to go back up here in terms of color coding, this was my yellow piece, okay, that I pointed out there. Then I had the blue, then I had my green, and then I had my pink. All right, now when we plug in the numbers, as long as all of these clean up to the exact same value, then we can say that they are proportional. All the sides are proportional. So let's see what happens. I'm going to now fill in WX actually had a length of 12. So I will write 12, compare that to PQ, which had a length of 8. Then XY had a length of 18. I'll compare that to QR, which was 12. YZ had a length of 15. And then RS had a length of 10. And then ZW had a length of 9. And SR, oh, sorry, I realized there's a mistake here. This should be SP. I think that is a P, just not really written very well. So that's actually P there. Okay, so SP should actually be the side length that has a length of 6. So I'm trying to figure out, is 12 eighths the same as 18 twelfths, which is supposed to be the same as 15 tenths, which is also supposed to be the same as 9 sixths. So let's double check. 12 eighths, I will get 1.5. 18 twelfths, I will also get 1.5. 15 tenths, I will get 1.5. And then 9 sixths, I will get 1.5. So because these are all the same, we are allowed to say that the sides are proportional. And because they are proportional, then we have verified, or we've identified, proven that those two polygons are in fact similar polygons. So, but they are similar. All right, example 2. So same type of question. We want to determine if ABCD is similar to EFGH. So reminder, if we want to prove if it's similar, are the corresponding angles equal and are the corresponding sides proportional? Reminder, this weird little symbol there, okay, that just tells you that it means is similar to in terms of the question. So let's start with, are the corresponding angles equal? So I'm going to have angle A, I'll keep going, angle B, angle C, and angle D. Okay, remember, the way this is worded, technically, if they're similar, A is supposed to match E. So I'll write that down here. So angle E has to match up to angle A. Angle B would have to match up to angle F. So we'll line them up. Angle C would have to line up to angle G. And angle D has to match up to angle H. Now, if I look at my diagram, it might look like I'm going to get stuck. So if I start with angle A, there's nothing here, right? There's no tick mark, no dot, no triangle, star, etc. Definitely no value. But if you look at the shape, it's showing that this is a 90-degree angle. Okay, so these two lines are perpendicular. Well, these are also perpendicular. So actually, this is 90, and that's 90. So the polygon we're looking at, it's technically a quadrilateral, but we would actually refer to it as a rectangle. So all of the angles are 90 degrees. So I will list those. So 90, 90, 90, 90. Look at your big polygon. Technically, it's a quadrilateral. There's 4 sides. You know it better as a rectangle. So again, if this is 90 and these sides are perpendicular, these are also perpendicular, these are perpendicular, those are perpendicular, which means the little square tells me that they're all 90 degrees. So that's 90, 90, 90, 90. Okay, so obviously angle A matches angle E, B matches F, C matches G, and D matches H. So this we've proven. Okay, so let's check if the corresponding sides are proportional. So you'll notice on these diagrams, they only give you 2 sides. Now, the reason for that is if it's a rectangle, if I know that this is 5, this is also 5. And if I know that this is 2.5, well, this is also 2.5. Okay, so I don't have to show all 4 of the proportions, setting them up with the side lengths, because these are going to repeat, right? So side length BC is matching AD, AB is matching. So I'm going to just go with small, comparing it to big. Reason why small is on top, just the diagram comes first. Okay, so now let's look. We are going to compare side AB, okay, which, based on my angles, I know is supposed to be proportional possibly to side EF. Okay, so I'll write that down. So side AB, I'm comparing it to side EF. But then I want to check, well, what happens with the other side length I know? So what about BC, which is proportional, or we're going to check if it's proportional to FG. I guess maybe say that it's connected to. So we're looking at side EF, comparing that to F. Oops, let me fix that. Not the same shape. Okay, so sorry, we're comparing from the small BC, comparing it to FG. Okay, let's plug in some numbers. So AB, I am comparing 5. I'm going to drop the units. So I'm comparing this side length of 5 to this side length of 8. And then BC, I'm comparing this side length, which is 2.5, to this side length, which is 5. Okay, so if I then calculate that, 5 divided by 8, so 5/8 is 0.625. And then 2.5 divided by 5 is 0.5. So we are noticing that those sides aren't matching up, which means these are not proportional to each other. So we could say the polygons A, B, C, D, and E, F, G, H are not similar. And if you want to be super fancy, you could say why. So because sides are not proportional. Moving on to example 4. Same type of question. We're going to be looking for a missing side, but probably what you're going to notice right away are the polygons that are given in the question. This time it's not as simple as I took this first polygon and made it bigger, made it smaller. So you'll notice the second polygon is smaller, but it's also been reflected. So it's almost like this shape was reflected over this line. So all that means you got to be really careful when you identify which sides are corresponding and which angles are corresponding. So what I would do, they're telling me that ABCD is similar to NMPO. So I know from that, the way it's labeled, angle A is going to be the same as angle N. So angle A is going to match angle N. Angle B is going to match angle M. So angle B is matching angle M. And then angle C is matching angle P. So C is matching P. And then last, angle D is matching angle O. So D is matching O. So what you'll notice is this polygon, they're labeling it in a clockwise direction, so A to B to C to D, right, according to the way it's written. But the second polygon, this one's not in clockwise rotation. So they're actually going counterclockwise and saying it's N to M to P to O. So that's how I know that there's been a reflection of the shape. Okay, but what's important, as long as you have the correct angles connected, you'll be okay. So this time it might help out to identify the sides that match. So if I go from A to B, so I'm going from the circle angle to the square angle, that's the side length of 4. Okay, well what I suggest, now match that up with your second polygon. So find the circle angle, which was N, connect it to the square. So that means that from A to B is the same as from N to M, this way. I'll keep going around. So B to C, so from my square angle identified to the triangle, is the same as from M to P. So from square angle to triangle angle, just the way that I've identified them. And then C to D, so going from what I put as a triangle to just my 3 lines, is the same as from the P here, which is the triangle, to the O, which has the 3 lines. So side CD is proportional to side PO. And then process of elimination, we have sort of run out of sides. That means that from D to A has to be proportional to O to M. Okay, now the reason why I do that, it's going to be easier for you to set up your proportion statement to solve for that missing side. So I know that I am trying to find missing side, which is right here. So I want to find this one. Okay, now I always like to put what I'm trying to solve in the top left-hand corner. So I'm going to flip it this time and actually look at comparing the small to the big. Okay, remember I said you can have this on top, this on the bottom, or this on top, this on the bottom. It doesn't matter. So if I have the small on top, I'm trying to say, well, what's the value of x? So this right here. Well, I know that OP is corresponding to CD. So side x is corresponding to this side, which is 6. So I'll go x over 6. Okay, so here's the side I want. That came from here. And then here's the side that I know, and that came from here. And I'd already identified that those sides were corresponding with my green highlighter. Okay, then we're going to look. So I'll go back to the small shape. The only other side lengths I can pick from, well, actually I have two choices. So I could use the 3 and the 5 or the 2.5 and the 4. Maybe I'll show you that actually both would work. So let's use the blue first. So I'm going to compare the 3. Okay, so I'm going to compare the 3 to the 5. So those ones come from the blue. Now, when you're setting up a proportion statement, if you're trying to solve for an unknown, you're just going to use 2 parts at a time. So from here, I can do half my cross multiplication, or whatever makes sense to you. If you want to do the full, go ahead. I'm going to show that it's 3 times 6 divided by 5. So I'm going to get 18 divided by 5. And I will find that x would have a length of 3.6. And there are no units there, so that would be my final answer. Now, this question did give you 2 other side lengths you could use, so let's just actually do a check then. So we can verify using the other 2 sides. You don't have to do this. I'm just showing that you could have picked the other sides. So I also could have gone x over 6, so still comparing x to 6. But then instead, I could have used this side, so 2.4, and compared it to this side, which is 4. So instead, I'm just comparing green side, and then yellow side, yellow side. If I were to cross multiply here, you would get x is equal to 2.4 times 6 divided by 4. Running out of room there. 2.4 times 6. This would give you a value of 14.4 divided by 4. And if you calculate that, you will notice you still get the exact same length. So this question actually has 2 possible ways for you to solve it. Let's look at one last example. So example 5. What I wanted to do was cover a question that was a little bit different than the last 4, I guess. But keep in mind, it's impossible for me to be able to cover every single type of possible question that you may encounter tied to similar polygons. The hope is that based on the examples I've given you, that you will have a good understanding of the fact that the angles have to be equal with similar polygons and that the sides are corresponding. So number 5 is more of, I guess, somewhat of a real life situation and or / word problem, if you want to think of it that way. But you'll notice right away, it just has like random side lengths. There's no labeling, so they're not telling you which angles are connected. So we're going to have to do a little bit of that work on our own. So it tells you, piece of cardboard is cut showing the inner outer boundaries of a pair of similar quadrilaterals. We want to determine the missing sides for the inner quadrilateral. So imagine what's happening here. You have this outer quadrilateral. We'll highlight it in green. Okay, so that's like the outer quadrilateral. And then imagine what you've done is you've taken that outer quadrilateral and then you've applied some sort of scale factor to each side to reduce it down to the inner quadrilateral. Okay, so you've applied some scale factor to each side, and what that's left you with is this inside, so the smaller, or what they're referring to as the inner quadrilateral. Now, what that means then, if you look at this diagram, to me, it's like the shape, right? So you had this outer quadrilateral. It's been reduced down by some amount to get that inner quadrilateral. So I would notice that whatever this side was, that was 12, we applied some scale factor to it to reduce it down to the 8. Okay, and we're going to have to figure out what was that. Well, whatever that value is, it would have to also get applied to the 16. So the exact same value would get applied to give you this length. It would also have to get applied to the 21, exact same value. Okay, it would have to get applied here. And then it would have to get applied to the 10. So then the exact same value. What did you multiply it by? So what did you reduce it by to get that inner length for that inner quadrilateral? So I'm going to set this up a little bit different. I want to figure out, so I know that for sure outer quad was reduced to end up with inner. Okay, I'm saying quad just so I don't have to write out quadrilateral, save some time for you. So the outer quadrilateral was reduced to end up with the inner quadrilateral. Reason why that's important is if it's been reduced, okay, so this is tying back to the first section of this unit. If it's reduced, then I must have had some scale factor, and it had to be less than 1. Okay, so on this question, we're actually going to look for the scale factor first. So I'm going to say, I want to find the scale factor. Okay, well, remember, by definition, we said scale factor, you can find it by taking your diagram length and then you divide it by the actual. Excuse me. So our diagram length that we end up with, that's the inner quad, so that was our 8. The actual, what we started with, was the outer quadrilateral, which was 12. So I can go 8, compare it to 12, so 8 divided by 12. I'm going to write it as a decimal, so I would write this as, I'm going to keep 2 decimal places, I'm going to say it's 0.67. Okay, so it's actually 0.66666, never ends, so I'll round it to 2, I will say it's 0.67. So now what I know is to go from the 12 to the 8, I timed that by 0.67. Well, if these quadrilaterals are similar, then I have to also times this by 0.67. I have to times this by 0.67. And I have to times this by 0.67. Okay, so really important, if they are similar figures, you have to be multiplying by the exact same number for every single side. So if we do those calculations, if I go 16 times 0.67, so I could actually say that this would be 10.72. I'm going to keep 2 decimal places just because the scale factor had 2. You could say it's 10.7 if you wanted. Then I would go 21 times 0.67. So this one would actually be 14.07. And then 10 times 0.67 would be 6.7. So the diagram's getting kind of squishy there, but I'll just sort of redraw this. Not the best, but this would be 10.72. This is 14.07. This is 6.7. And this was the 8 that we started with initially. So the answer to the question, they wanted you to state this length, and that length. So we could say the missing sides are, and then you could list them. So 10.72, 14.07, and 6.7. Okay, and again, if you kept 1 decimal place, that would be fine. I just happen to keep 2 because I kept 2 with my scale factor. So a bit of a different question. Now what I suggest is if you can in your textbook, you're going to look at page 157, practice question number 5. It's very similar to this last example that I went through with you. And then I will also post an additional worksheet that I would like you guys to practice and then send me a picture when you're finished just so I know whether or not you're on track. And please, 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 if you have questions, fire me an email. Let me know how things are going. And other than that, have a wonderful day.